Sketch the graph of y is x minus 12 divided by square root of x squared minus 4. Write down the x-intercept, the equations of all asymptotes. Let's start with vertical asymptotes. You know that a vertical asymptote arises only if there is division by 0. So we can see the denominator, it's a square root, but square root is 0 when this expression on the square root is 0. So x squared minus 4 is 0, and we can see that there are solutions, and solutions are negative 2 and x is 2, and these are our vertical asymptotes. A vertical line, it's what? It's just x is a number, it's a constant. What about horizontal asymptotes? To find a horizontal asymptote, we consider its actually limit x tends to plus infinity, and also you should consider x tends to minus infinity. You may give the same, but it may be that there exist different asymptotes. So in general, you should consider when x is very large positive and x is very large negative. And when x is very large positive or negative, we take into account only the largest powers of x. And here, and we ignore all other powers of x. And when x is very large positive, y acts like x divided by, but square root of x squared is the absolute value of x. And you can see that we get same powers of x, so horizontal asymptote exists, and it's just division of coefficients, and it's just 1 over 1, so y is 1 is the horizontal asymptote, and its limit when x tends to plus infinity. So y is 1 is a horizontal asymptote. It's when x tends to plus infinity. Why I write tends to plus infinity, x tends to plus infinity, because it's an example when there are two horizontal asymptotes and they are different when x tends to plus infinity and to minus infinity. Again, x over square root of x squared, which is the absolute value of x. But when x is very large but negative, it's negative, but it is positive. So and again, horizontal asymptote, because powers are the same, it's just division of coefficients 1 over 1. So not 1 actually. X is very large negative, and x is positive. Yes, coefficients are the same, so it's 1, but since x is negative, y is negative 1, it's a horizontal asymptote. I mean that if it would be 2 and 5, it would be negative 2 over 5, because we consider x is negative, so it's like additional minus. I hope it's clear. So y is negative 1. It's the same as x is negative million. So because there are no coefficients, or 1 and 1, it becomes negative million over million. So is horizontal asymptote. It's when x tends to negative infinity. And you remember that if greatest power of the denominator is greater than the greatest power of the numerator, y is 0, it's horizontal asymptote. It means just graph falls on x-axis. And if the greatest power of the numerator is greater than the denominator, there are no horizontal asymptotes. And what about x-intercept and y-intercept? To find y-intercept, we should consider x to be equal to 0. But you can see that when x is 0, square root of negative 4 doesn't exist, so there is no y-intercept. And also there is a domain, because square root cannot be equal to 0. It's because denominator it also cannot be equal to 0, but square root must be all greater or equal than 0 in general. But since it's a denominator, so x squared minus 4 must be greater than 0. So x squared might be greater than 4. So x is greater than 2 or greater than -2. So we will sketch a graph, or this curve exists only for these values of x. And you can see that y-axis is in between, where this graph doesn't exist at all, so there is no y-intercept. And what about x-intercept? It's just we should consider y to be equal to 0, and you can see fraction to be equal to 0, just numerator is equal to 0, denominator cannot be equal to 0, and you can see it's just 12. So x-intercept is just 12, 0 as a point, or just x is 12. And now let's sketch this graph. So there are two vertical asymptotes at -2 and 2, and there are two horizontal asymptotes, -1 and 1, -1, 1, y, x, and x-intercept is 12, and it's clear that y is 1 is when x tends to plus infinity. It's clear that it looks like this. It must be smooth curve, something like this. And you can see that there is no x-intercept here, and it's because it falls on horizontal asymptote here and on vertical here. So this graph looks like this. And that's all for this question.